favorite phase of the moon up. I happened to stay awake tonight. Figured it was looking clear, so just a little extra. This is probably the last stream I'm going to do for the week, but it's gorgeous. It's a 27% waning crescent coming up right now, a little bit north of east for me. What up there, Justin? What up there, Z Proxy? And whoever else is hanging out. What up there, Tux? How are you? So it seems like the prominent features tonight, we got Aristarchus Crater and Plateau. You'll be able to see Schroeder's Valley. We got Kepler right on the Terminator line and Kepler's Shadow. We got Mare Humorum and Gassendi Crater towards the bottom middle. And then at the top, we got Sinus Iridum being cut by the Terminator, Mare Frigoris and Anaxagoras up at the top. What's up there, Seamus? Good morning to you. Isn't it? Such a gorgeous view. This is like I said in the title, one of my favorite phases of the moon. This and probably like first and last quarter are great. Yo, that sounds pretty awesome, Justin. Have a great forest walk. What's up, the foreskin vampire slayer? Is it a hologram? No. At least I'm 99.99% holographically sure that it's a real object. Now, that doesn't mean it's not incredibly insane and magical and almost like just unbelievable that it exists, but you definitely can't see through it. And if you want to prove that, you can get a scope and follow the moon, but also you can check out my playlists and you'll see there's a video from 2015 with a Venus transit, and you'll see that Venus goes behind the moon and it's during the day, and there's no confusion as to whether the moon is translucent or see-through. And further, I also have caught the lunar wave, so-called wave before, and so that I also don't think means it's a hologram. My best guess for it is it's some sort of like plasma sheath, potentially. The moon goes in and out of the Earth's magnetotail once a month, and so potentially it's one of those things where the moon enters through a double layer plasma and it creates those two passing waves. Yo, what's going on, Constantine? Blaze. All right. So I'm going to zoom in on a couple of the poignant features that I mentioned. Let's first take a look at my fave, Aristarchus. So Aristarchus tonight, seeing it from a completely different angle, you can see it almost like from up top. And Schroeder's Valley, the kind of winding, I want to say dendritic pattern or line flow. It's going to be very visible in a little bit, but you can see it right in the center of Aristarchus Plateau. And then the little crater to the bottom of Aristarchus crater is Herodotus, or the Cobra Head. But it actually doesn't look like it's connected to Schroeder's Valley. Some other regions north of Aristarchus, and this is a lot of what I was reading about from the Ralph Jurgens paper, where he's talking about a bunch of sinuous rills around Aristarchus. Just brighten this up a little, we can see what's going on. There we go. To the right of Aristarchus, you got Kepler with its fine rays coming out. It's nearly engulfed on the right-hand side by the Terminator, and it shall be more so soon. And what do we got down here? We got Mare Humorum with Gassendi on the rim of Mare Humorum, and then you got a subset craterlet of Gassendi on the rim of Gassendi itself. So a great example of electric scarification on large scale and smaller scale. Yo, what's going on, YoQ? No cheese, possibly hollow. Space station, who knows? Created by who, what? Still don't know. Is there a reincarnation matrix? I don't think David Icke is right. That wave video is intriguing. Cool. I'm glad I could answer some things. Yep, South Florida right now, 3:31 a.m. Eastern. The weather cooled off a lot today, and I was honestly, it was said it was going to be cloudy, but I got a beautiful moon in front of me, so I'm not complaining. So particularly, the reason I mentioned electrical cratering is because I believe that moon craters are not really created from impacts, or at least the majority of them are not created by impacts, but rather electrical interactions between planets, perhaps the moon and Mars, or the moon and Earth at some period. And one of the reasons is that you have these smaller craters on the rims of larger craters, preferentially. I'll lower this a little bit. Let's put something a bit different. Yeah, so that's one of those types of attributes to electrical scarification, to have these smaller craters on the rims of larger craters, as opposed to the opposite, which we almost never see on the moon, which is smaller craters and then you have a large crater superimposed on that. That's something I don't think I have seen, but I'll keep a lookout. So Mare Humorum, and right under the Terminator you got some nice examples of sinuous kind of, I don't want to call them rills, because rills are really the fine, sharp gullies, but you can see they're almost dendritic structures themselves, or filamentary structures, but they're land or regolith, like shelving or landslides. But it also could be land that was pushed out by a strong electrical discharge slowly. Yo, what's going on, Tom? What's going on, Ratch Kate, or Rach or Rack Kate? Foreskin Vampire says, right, electromagnetism is the true law of governance and relation regarding space. Yeah, intrinsically, I think everything is electrical in nature, and electricity in different states or phases and plasma, I guess, create almost everything we are and see. and we are within it, therefore we're connected to it instantaneously. And that really just explains a whole ton of different things that we see and things that we postulate metaphysically or astrologically are also make perfect sense under an electric universe paradigm. Now, are people resistant to it? Certainly. I read so many comments where people are just like, will not even entertain EU, but perhaps in the future. One more feature before I zoom in. This is the edge of Sinus Iridum, or the Bay of Rainbows, half in shadow. This is one of the real features that I love at this phase. It's super rare to get that kind of harsh shadow across such a prominent feature. Yeah, Constantine brings up a great point about central peaks. So I've been looking into central peaks, and I don't know everything about central peaks, obviously, but there are a couple of things worth noting that from analysis, from spectroscopy, which I can't do, but if you take that as real fact, so apparently the rock or the rocks or the objects at the centers of these craters are actually the same composite as the walls of the crater. And the walls, that actually means that, let me lower this a little, getting distracted. Yeah, that just means that it's not strata that's been dug up from an impact, and it's also not from an object actually hitting and creating this crater. So the rock is the same as the outer rims, as the center peak. I know that was a sloppy explanation. So that's one reason, and I'm going to try and quickly find a crater with a central peak right now, but yeah, we can look at Gassendi. Gassendi is actually a great example of a stratified crater, and you have different features, like geological features within Gassendi crater, and it has all the telltale signs of what look like electric scarification to me personally, and you know, Thunderbolt's project, of course, messes with it. Actually, they're the ones who really put it forth and brought up the work of Ralph Jurgens and Hannes Alfvén, and then others, people like Billy Elverton and Ben Davidson were doing lab experiments with Michael Steinbecker and a bunch of the EU people, and they were looking at electric discharge in the laboratory, and they came up with this. So I'm just piggybacking on that work, but with real moon footage. It makes a lot more sense to me when you look at it for real and then you talk about it and you can look at it. So I'm repeating myself. So here we go. We have the walls of the crater. So this is about 80 kilometers across, and you have central peaks. And in a couple of minutes, I'll switch up the lens and we can look up a little closer. But the central peaks, I think, are due to the fact that if you have a very high discharge arcing situation, that at the end of the discharge, when it breaks the connection with the surface or the anode, you have this kind of pulse wave effect. And it's been noticed in a couple of lab experiments. It's been noticed in the Sapphire project, the stuff that Thunderbolt's project talks about. So this blowout at the end. And so I feel like that would be the node point, leaving kind of a central peak where that magnetic disconnection happened. But that's just what I think. I could be wrong. But the other aspect of this is flat-floored craters, where the popular postulate is that they're like melted floors, lava melting kind of an iron regolith and flattening it out. But very easily, if you have an incredibly huge discharge arc happening on the surface of the moon, it could equally boil the surface and create like this flat floor that we see. So Gassendi crater, central peaks, high walls that match the rock composition of the central peaks, and then you have a small crater, Gassendi P, I believe, on the rim of a larger crater, and that is also due to a certain type of electrical effect as the arc moves across the surface, tries to find a high point. But to be honest, that's a little bit fuzzy for me in terms of how that science, like the math actually, how the electron charge shifts and the ions shift. That's a little bit not really my forte, but I think I sort of visualize how it could happen. And so then as soon as the arc breaks, you have its residual kind of like figure eights and or adjacent mini craters or large craters. The other thing about Gassendi about certain craters that are electrical in nature are hexagonal and pentagonal forms. Gassendi happens to be quite round, or at least very round as we look at it now, but if you kind of focus on all lunar craters, at some point or another you get these kind of sharp walls. So that's what I'm going to be looking for in future shows. Tonight, really, we only have Gassendi to look at in terms of that type of crater. And the other really important features of electrical scarring are these dendritic filamentary structures that are mistakenly identified as ejecta and are supposed to be made on instant impact, but if you really look at them, these things kind of grow outwards. They have branching, they have path of least resistance, they have dendritic structures and filamentary structures. Looking at Aristarchus right here. Yo, what's going on, Fast Pace? How's it going? And Moo Bear. Rachel's and Rachel, got it. Cool. What's up, Ashlyn? How's it going? Welcome. Welcome to everybody hanging out this morning. 3:40 a.m. South Florida. It cooled off a bit, but now it's cooking. I'm gonna switch up the lens, stretch the legs for a moment. I'll be back. back on the mic. We got a closer view. We got the smoke review. Yo, what's going on, Sebas? Ça va, mec? Long time indeed. It's so funny, I was saying the other night that I was going back through comments from years ago, liking them, because I missed so many over, I don't know, it was just madness how many comments came in. And so recently I was just cleaning up the channel, and so I was hitting up some likes on comments, and recently, like the last couple of nights, some people from way back started coming back to the channel and leaving a comment, so that's cool. It's like an old reminder to an old friend. Good to have everybody here on this beautiful space journey. As always, another one on the edge of reality. So cool to just be deep in adventure every second during these experiences, these shows. Just as much as y'all are with me. Anything could happen, and we're watching. So there were storms all day, so you're gonna get a little bit of that atmospherics. But I'm zooming in here on Aristarchus. Good to hear. Awesome to have everybody here. Man, it's a packed house. I love it. Rolling into the weekend. Gonna chill tomorrow, sleep late. So I'd love it to be just a little clearer so we can see Schroeder's Valley in better detail, but I'm gonna zoom in no matter what, regardless. So let's take a look. We got Aristarchus crater is the prominent one with the dark feature, and to the left, actually the bottom left of that, like the 7 o'clock position, that is Herodotus. It's like a flat-floored mini crater. Both of them are about 50 kilometers across. And then you have the Snake Valley, or Schroeder's Valley, that kind of traverses the midway point and then curves around on what they call goosenecking, almost like what a river does. And then it kind of curves back around, and that's about 100 and some odd kilometers long. And then it almost does another type of sinuous rill that kind of travels off to the top left. The whole thing looks like a lightning bolt itself. But this is one of the key features that indicates electric scarification, and it's one of the very, very prominent features on the moon that anyone can take a telescope and see. And further, when you look into research on Aristarchus crater, it's quite limited in terms of popular science. So either people are ignoring it on purpose, or people just really haven't considered the ramifications of what this object or this feature is. So you have Schroeder's Valley, of course, and then the entire region around it, you have almost what is, you want to say a diamond or a square. So you have almost sharp sides, sharp corners. I mean rounded corners because of geological formations, but essentially a square. And then further you have all the dendritic and filamentary kind of marks or rays coming off of the... Actually, the whole region is emanating those rays. It's not just Aristarchus crater. And then one more thing would be the fact that Aristarchus crater itself glows or shimmers, and this is due to several different factors, or at least it's postulated that it could be off-gassing, which is because the moon has almost no atmosphere. The vacuum kind of strips ions off of the surface directly, and you have some sort of electrostatic effect with either dust or just kind of plasma discharge. So there's no denying that there's electrostatic energy on top of the moon's surface. and a very slight electric atmosphere. And we don't really know exactly how much of that we can really see, because I've never seen any research done on it. And the large telescopes don't show us pictures of the moon. So we're left speculating. All right, quick wide shot footage, because I'm trying to compile some nice shots for future kind of compilation videos, and then we'll zoom down to Mare Humorum Gassendi crater and take a look at that again. Should also be able to take a look at Schiller crater and Schickard crater, the two very elongated, what are probably the 2 or 3 that we can really see that are actually not circular. But in fact, they don't really show like oblique. They don't show oblique impact. They actually show almost like carving of an elliptical area with a flat floor. Very similar features to what we see with many of the craters, but just elliptical. Yo, what's up, long time Chow Yan Cat? Can I play the sound of pea soup or water boiling on the stove to this footage? It's a little bit far away right now, kitchen-wise, but I can definitely hit the lighter sound. Yo, what's going on, Hazmat? Electrical Universe Host Show. People are just mad because their old scientists are dying off. Although I shouldn't really say that, because really plasma cosmology is as old as relativity, if not older. So we just have to kind of rectify the course of physics, no big deal. It's gonna start small. It never really happens from the top. They're the last, as Wal Thornhill recognizes, the last to know when a paradigm shift has occurred. So they're going to keep clinging on and defending the old paradigms. But ultimately, Electric Universe is one of those things that everybody can be part of, because it's fundamentally understood by the layman. All right, for the last shot, sure. Yeah, good note. Like, so, you know, you have all these fossils, and then you have the tie-in to the mythological Medusa with the flaming hair, or the snake head, snakes on the head, from Clash of the Titans, right? And so Medusa would turn men to stone, or warriors, or anything really to stone. At the end, it defeats the Kraken, right? So if you really tie in the Medusa archetype or mythos to Electric Universe, in terms of there were people on Earth who saw a comet with fiery hair, like snake-like hair, that actually was zapping people and animals and objects like trees and rocks, and essentially transmogrifying them and like natural alchemy. You know, it's unbelievable that people were actually seeing this, but these are what the myths tell us. The myths are history, and they've been treated so poorly and been distorted by the powers, because it's much easier to manipulate people if they don't understand their history. Can you imagine all the writings that have been absconded with from different wars and library lootings, not just the Library of Alexandria, but any number of, if you look up destroyed libraries or looted museums over the years, you'll see it's just a litany. So think about that information while we dig in with real lunar footage. That's all we can do right now, right? But it's a lot. Seeing the moon for real changes your perception of reality, changes the way you approach things. For me, it's one of those things where, you know, don't take my word for it. Go buy a scope and look at the moon and determine, you know, learn geology, learn about the space around you. Everybody needs to take responsibility if they care about it at all. If they don't care, you know, whatever. But that's what I think. Yeah, all good. All good. All right, let's zoom in a little bit here. I mean, for those who haven't listened to the last couple of nights, I've been talking about the fact that there are these historical records, one particular from Homer, talking about how Mars and the moon had a dance of electricity in the sky where they had, you know, tethered by what is probably like a giant Birkeland current that people could see from Earth and wrote stories about. That's an unbelievable visual to imagine. All right, zooming in here at Mare Humorum and Gassendi Crater. One of my favorites. So there are a couple of interesting anomalies about the moon. There are these dualities or triplicates, but mostly duplicates of these very prominent features. So unfortunately tonight you can't, or you can, it's interesting because when it's a full moon it's really hard to see Gassendi Crater like we're seeing it now in nice relief. But it's the only time you can see Posidonius, which is on the rim of Sea of Serenity, which is now in full shadow, and Gassendi, which is it's like a sister crater. It has a similar type of wall structure. It has craters on the rims of it. It has stratified interior, central peaks, and kind of little sinuous rills like cuts in its flat floor. And it has just such a similar feeling to Posidonius, but anyway, just making note of that. Let me brighten up the image a bit. Alright. We got a nice shot of Gassendi crater. Adjusted the focus, got rid of the focal reducer, so it's the camera direct to the 11 right now. That was a little cactus dance. Just like pause that for a moment. And so you can see the central peaks of Gassendi, 3 little pyramids, right? Exactly. Obviously not exactly mirroring the Giza pyramids or the Belt of Orion. However, it is extremely interesting in terms of, impact crater versus electric discharge machining. And so this is really one of those tests where I feel like I've gotten to this point where I want people to look at the moon and just decide for themselves whether they think that something the size of these craters could come in and blast a hole like that and leave a feature so sharply defined and very little residual rubble and almost perfect circles or hexagons and pentagons versus having this kind of organic growth come from electric discharge hotspots that we see like welders' arcs and sputtering. And it's dumb simple. This is one of those key things that if you identify that the moon has actually been scarred by electricity, then you have to, the next question is really like which planet or which body created that, and then you could really determine the charge density, and you could probably figure out a certain tie-in to a certain epoch as to when the moon was in our skies. I feel like I said earlier, there's a ton of information that we don't have, but I can imagine that it talks about when there was a moon in the sky and when there wasn't a moon in the sky, for example. Or if there was a moon, like who took the first pictures and who's, if you try and dig in right now to lunar astronomy on YouTube or on Google, it really is very limited. You get a lot of stuff from the 50s and 60s, you go back to the 10s and 20s, you get very little data, and before that it just becomes archival. And I've done that dive many times, obviously, many times, I should probably repeat it many times, but either way, that's what's going on. So Gassendi crater, perfect example of what we're talking about, and if it were a little clearer, we could see the little sinuous rails littering the floor, this flat kind of melted floor. I see the video output is looking like it dropped some frames, but no worries, I'm still going. What's up, more Jello, please? What's up, Cichlid Visuals? What's up, Microwave Soda? So I was also talking about the word crater and feeling like it was a misnomer, but in fact, crater is referential. The original word is something like a bowl, and that's possible, but really, I think the word might need to be changed because these so-called craters are really flat-floored at this point. Not just the large ones, but especially kind of the ones that litter the surface are really just smoothed out. You can't really tell how deep they are, and the walls almost jut out from what we know as the surface of the moon. So I've spent a lot of time here on Gassendi. I'm just looking for my remote. There you are. Let's record a little bit of wide footage with this changed lens, and you can see it. Mare Humorum and those kind of folds up top. And you can see Gassendi on the rim, and then Gassendi A is the small crater on the rim of Gassendi. So that is just such a indicative feature. I mean, the odds of that happening are also staggering. Look at the mathematical geometric precision of where Gassendi is in relation to the larger Mare Humorum, and even Mare Humorum at some I think. If you kind of look right under Gassendi crater, Mare Humorum actually looks like a straight line coming down, and then it looks like an angle, and then it looks like another straight line. In fact, Mare Humorum itself looks like a large hexagonal feature. And let me know if you can see that. Drop me a note in the chat. Hazmat makes a good point that I want to address, because this is always kind of a debate that goes back and forth about craters come in at angles, never directly. So there's an argument for both, right? Plasma definitely hits from above. So plasma is definitely part of the possible reason that there are craters, but impacts, apparently the popular discussion is that they don't actually need to come in at whatever angle, because they explode over the surface and they create circular craters. And so that's one of those things that's very hard to debate, because it's almost like looking at evidence and making certain assumptions based on preconceived ideals versus just looking at the actual evidence and throwing out everything. A lot of people think that Electric Universe people are tied into all sorts of conspiracies, but it's not really like that. Electric Universe is very geometric, very scientific, and very observational, and it's like, I think, true classical physics, and much less this kind of hokey flag pin type, I don't know, it's nostalgic physics versus new observational physics with amazing technology. So, yeah. Beautiful examples. Let's look at Schiller and Schickard crater, which are actually elongated and not due to the fact that the moon curves. Yeah, the features do seem beat up for sure, and it takes a second to kind of to grasp whether they're hexagons or not, but if you just kind of follow one edge at a time, you'll see how really the angles start forming, and you have straight lines and an angle, straight line, angle. Even now we're looking at, let me confirm what this is. I think it's Schiller. No, this is Schickard. Schickard, Schickard crater. One of the true elongated. But I wonder, really, that's also being stretched, foreshortened, as they call it. So the waves that we're seeing right now, that's due to atmospheric turbulence, I believe, on Earth. So the same thing with the orange rim, that's refraction, not gravitational lensing. Magnets could change its direction due to impacts. Is that what you said? No, magnets could change its direction to direct impacts. Yeah, that's possible. I mean, the main thing with impact craters for me is hexagonal and pentagonal craters. Then there's the arc, the ray systems, and then the small craters on the rim of large craters, and then you have the central peaks, all of which cannot be reproduced in simulations in the laboratory or on computers with ballistics. Ballistic craters look like mounds, or they look like oblique errata, kind of strewn, stretched craters, which we don't really see a lot of. Especially things that we can see from Earth are, 5 to 10 to 100 kilometers across. If something the size of 50 kilometers hit the moon, I think you'd see tons of debris across the surface, and we don't see any of that. So in fact, like all the PopSci articles that talk about, oh my god, all the circular craters on the moon, in fact, should dig a lot deeper before they come to no conclusion, which is what most phys.org articles get to, really just big question mark. Yeah, what's up, Lost Brooklyn? All right. And then at the top right of the screen, this is Schickard crater. It's also an extremely elongated crater. So this would be one of those things where I guess an impact would come in at an angle and strike the moon and kind of maybe skid across the surface. But if you really look at this, I mean, sure, it's a bit dim. I'm gonna actually raise the gain here. Yeah, this actually looks really pretty good. It looks carved out. You can see almost scalloped dendritic ridges towards the bottom half of it. I mean, I'm using terminology that I heard Thunderbolts project talk about, obviously, so I don't want to sound like I'm just regurgitating that shit, but you can really see these, the sharp cut form nature of it, cutout nature of it. So for me, it's really observational and trying to rationally deduce ideas from these observations and from experience. Also looks cool. So insane. All right, so Chickered Crater, and let's put on a song for Chickered Crater. Something chill. Is it a concave moon? I don't know. I'm actually pretty sure that, I'm not sure actually, but what I really lean towards is like a very thick outer crust and almost the hollow moon situation, almost like the nucleus and the electron cloud, just like all planets and Jupiter and Saturn very likely seem hollow in terms of plasma cosmology, but that's just where I'm at right now. I used to think concave moon might be a thing, but you can really see that these features right now are just curving away from us. And Jupiter kind of has the red spot and that turns away from us. So the spherical nature of the universe is very, very evident in space. All right, let's quickly look up at Sinus Iridum before the clouds get jealous. This is an amazing region. This is the Bay of Rainbows, and you can see it really cut into the terminator, so the prominence of the outer walls and the rest of the mountain range. And so you have to imagine, like, how was this mountain range formed? You know, was it carved into the surface? Was it raised from below? Is it like tips of icebergs peeking through Mare Frigoris and Mare Imbrium? And then you have to think about, look at this, I'm going to center it, but you can kind of see this idea of a dendritic ridge, and a dendrite is like a neuron, if you want to visualize it. It just means like a little lightning branch. And so dendritic ridges are what you see in tons of Earth geology, but you're seeing it directly in the center of your screen right now, coming off the side of Sinus Iridum. And right next to it, in the actual mare, which is Mare Imbrium, you can kind of see a sinuous landfold or landslide. Tom says, do the Thunderbolts project claim to have some new optics tech, or is that someone else? No, they don't really talk about doing telescope work almost ever. I've only seen a few, like, amateur astronomers with interesting large telescopes, some European dudes, some alien channels, UFO channels, but I've never really seen, like, Thunderbolts actually deal with telescopes. I wish they would. I say it all the time, like, they should do live streams, they should do actual space footage when they talk about things. Even if it's really crappy footage, if it's real, people will, I think, actually love that. Especially when they talk about scarification, they should really use moon footage or live moon and talk about, and have Anthony Peratt or, what's his name? Andy Hall, or what's the other guy, Steve Smith, who was talking about Mars geology. Like, I'm really a newbie when it comes to Mars geology. That's because it's very difficult for an amateur astronomer to visualize Mars up close. And you really have to rely on all the NASA stuff for that, and I tend to not want to do that. But yeah, I don't think it... Anyway, the new optics tech really is just this thing called adaptive optics. And so adaptive optics uses computers to kind of analyze a laser signal that's projected out from right above the telescope and then shot back in, and then it sees the diffraction patterns of the laser and it accommodates for that, and then it almost reverse distorts the image so that it actually makes up for the diffraction of the atmosphere that, like what we're seeing right now in real time. So all the waving, all the waviness and the like little turbulence that we're seeing could actually cease to exist entirely. This is something that the Keck Observatory, I think Subaru or Keck have, Mount Wilson maybe. Certain telescopes have it, some don't, but adaptive optics is really the kind of future, besides the giant telescopes that are being built. What I think of Airy's experiment about proving we don't move, I just think that all of those experiments, I think there are too few of them, to be honest. That's where I ended up with all of that, because even up into the Michelson-Morley experiment, and you just see that like we don't have any actual evidence for that ourselves. So when you do experiments, you're actually in the experiment. That's what's really interesting about doing a lot of these round Earth, concave Earth. I think like we're inside the system, and I don't think we're separate from it. Anything we look for essentially will be there, which is why you have all this confirmation bias, and reality is almost defined by each and every person. So all we're doing here is basically agreeing, having consensus to believe that we're watching the moon, and that happens. I think I went a little meta on that, but it's really just about like what is reality. You know, you have to think about what is matter, what is reality, how does that occur? Do you create it with words and emotions? Do other people create it for you? Can you affect it? Is it co-creation? Those are the kind of thoughts that I have. So I'm not really sure about experiments that prove the Earth is flat or not flat, because I think that really doesn't matter, and it never really has to me. I've always thought that spheres were cool. And it wasn't because flat Earth is an interesting concept. It's just not a really physically viable concept, especially when you do astronomy. When you look at planets like the red storm of Jupiter just going somewhere, I mean, you could imagine that it's not going somewhere, but it is going somewhere. Same thing with the moon. These things rotate, and I've seen balls rotate, and that's it. It's very, very simple. It has nothing to do with emotions or trying to prove something one way or another. Because so what if the Earth was like a donut hourglass? Like, what would that matter? Like, you'd still have to wake up the next day and do shit. So I think that's why doing astronomy, for example, for me, is one of those things that it's not just like discovering hexagonal craters are not impact craters. There's also joy in seeing the moon and sharing it with people, in having a satisfying day, in smoking at 4:20 in the morning, and enjoying the weekend, you know, so there's still life in it. And I feel like conspiracies really suck the life out of life. Of course, very ineloquent at 4 in the morning, but you know what I'm saying? Like, so what if you figure out like that the government was lying about JFK or Apollo, or it doesn't really matter ultimately if you can't do something. Yeah, like even the idea, guys, like I know that you guys hang out here a lot. I'm not trying to like poke any flat earthers particularly. I'm just saying like you know, the Illuminati are these cats who monopolize and enslave humanity. Right now, like we can look at the moon, right? Until the day we can't, then, you know, they're enslaving us. But right now we're seeing the moon, so you got to be able to kind of, well, I have to kind of experience the moment right now and let those cats be the they in the background. They can't constantly be like surveying me and taking my blood and cloning me and watching me with 5G and Monsantoing me. You know, they can be, but that if that's my life, then my life becomes really dull. I think if you listen to the old philosophers, they were talking about how you just eat that and you just enjoy that you're gonna die, and then nothing really bothers you. And granted, that's the most difficult thing, is to not fear death, but once you can face death as a new transition and something that you're excited about, then nothing can stop you. I'm gonna leave your comment up because you can just see that writing something like that is completely ridiculous, you know? And it just proves something about you and not me, you know? You're the one in the chat room and I'm the one scoping the moon for the 10,000th time. So I'm sorry that there's this emotional tie-in that makes you kind of sling insults, but I feel like I've always advocated for politeness and equality and talking about science and stuff, because otherwise we can't really move forward if it's constantly just hurling insults and belittling people. You see that enough in popular science, so like the whole culture. Even today I went on phys.org and I was listening, there are articles about plasma science, you know, so plasma science is not really hidden. Plasma science is a real field and there are tons of people who do it, but it's just interpreted in different ways. So anyway, in the phys.org comment section, it was just like a bunch of adults like just hurling insults at jackass, and you don't know jack shit about plasma physics, like complete armchair warrior idiots. Excuse me, not idiots, people who just do not understand how to be polite about discussing important topics. And you know, we're all guilty of saying things like that, but I think tempering it and retracting those things, because it really doesn't move things forward. Actually, ultimately it's very boring when you listen to it objectively. Subjectively, it's sometimes difficult under the influence or late nights or with people. You kind of shoot the shit, you say random things. But if we're really talking about lunar geology or, you know, Earth science and history, there should be really a very respectful air about it. There should be graciousness and politeness and respect across the board for everybody, because that's where true collaboration and new ideas come from. If you isolate and group people together and then ostracize another group, then you're just doing exactly what you're talking about when it comes to the they. You're just another version of the they. The they. Alright, that's my little rant. I rarely talk about flat Earth on this channel just because I don't like to ruffle feathers, and it's just one of those things that really doesn't go anywhere. But that's my opinion on it. Everyone's still welcome. People are people, you know. Just because you have different science doesn't make you less people. And honestly, the reason I think that politeness is such an important factor is because it is so difficult to achieve. It is so difficult to actually temper oneself instead of being like, oh, you stupid jackass, you flattard. You guys hate that stuff, I'm sure, right? But like, it's the same thing as saying they're hiding when, you know, a ton of people who work at NASA are just also real people. And a ton of people who work at SpaceX are real people like you and me, and they're not out to get anyone. And so just sweeping generalizations of everybody just really does exactly what we don't want, or what I don't want. You know, so right now, like, we have no lobbying group against these massive amounts of satellites going up, like the Starlink satellites. And the reason is likely because everything is fractured in the citizen science world. Everybody is, you know, suspect of everyone else. In fact, I was listening a little bit to Tony Darnell again today, just because I you know, keep your enemies closer. No, he's not my enemy, but Tony Darnell, like, is the epitome of the dad astronomer who grew up with the space program and who wants NASA people on his show and who will toe the line. You know, but he's had a couple of shows where he's talking about Starlink, and he's disappointed in all of that. And then he had a show where he was talking about, what was it? He was talking to the guy from Sky and Telescope magazine, Mr. Kelly, and let's see. Am I missing anything in the chat? I'll come back to it. But anyway, he was talking to this guy about the fact that online he's actually noticed what kind of dissent there is towards contemporary science and pop sci. Because, you know, you go to these videos and you see, you know, 2,000 thumbs down and tons of comments like mixed flat earth, mixed ufologists, mixed just angry people, and then also EU people. And all these different groups are out there kind of, you know, vying for their own type of thing where it's like, I believe in some of this and some of that, but not all of that. And this is where cohesion really matters. And so I feel like maybe it's not about necessarily what people believe, maybe it's about picking and choosing your battles, or one's battles, in order to basically achieve small goals to move towards a larger goal versus really not moving forward at all on anything. So if the shape of the earth were revealed tomorrow, still you'd have to do more, you'd have to do other things. You know, you'd still have government and you'd still have infrastructure. Those things just wouldn't vanish because they're almost, in a way, they're so deeply tied to our society that, you know, you can't really be delusional about it. Or, I mean, people can be, but I personally think that infrastructure will go on. So if we want real, like a lunar program, which is what I want, you know, you really have to just get enough people on board to see that there is a new type of physics out there. There's an old type of physics that answers a lot of the big questions. And so I picked a tiny swath of science to stake my claim to, and back it up with observational science, which is what's missing, really. I think a lot of people actually don't like popular science because, and they don't really comment on it because, you know, most of it is renders and pictures and old footage and not real footage of today's space that people really see on shows like this and other shows like P&K and Chris Parker and whoever else does moon footage. Carolina Sky Astronomy and Astro Imaging Live and just, David, Astronomy Livestream, and Z Proxy and Cosmic Surfer, and a whole ton of people have done moon footage, and you see the status quo pop-size version of it, and it's always a render, it's always CG, and yeah, people are suspect. It's not because people are idiots. And so anyway, the long short story is that this guy Kelly on Tony Darnell's show was talking about how it's really the people that are stupid, people are just crazy, it's bonkers, and how it's just the whole world is stupid, and it's not that the status quo is stupid or has become boring or has become stagnant. And it's just unfortunate that two intelligent adults can't postulate that it's something besides what they see right in front of them. So I want to comment on that. Maybe one day Tony Darnell will join us and he can explain hexagonal craters, because that would be cool. What's happening in the chat? YoQ says, I need to start a podcast, even if it's just once a month, and I can be a guest or something, and you can be a guest on Crow. I was the first guest on his podcast. It's so funny. Everyone always says that. You can be on Crow's show. It's like, I was number one on his show. It was funny. But yeah, I mean, I want to expand TakeBackSpace at some point. It's just what I can do when I can do it. But obviously, 4:30, I love doing this. I love sharing the moon with people. It's just one of those incredibly obvious things when you look at the moon, that things are happening in space that are amazing. They're not boring 3D. They're not loopy, dystopian rhetoric. It's not comic book. It's not Star Wars. It's real deal crazy space, whatever that means. Even if we're inside a hologram, this is like the edge of the hologram. It's not inside our phones, although this is probably inside your phone. So I guess it is. It's all simulation, everybody. That's what I've been saying this whole time. It's changing my mind, changing my mind. Let's put an old jam, Chrome Fantastic. This song back on, but I want y'all to take a look right here, which is, I think, one of the trippiest things on the moon. So you'll see at the top left corner Aristarchus Plateau, Aristarchus Crater, right? And then to the right of that you'll see Kepler, which is half in shadow, and then it has the sharp rays. But look at the feature that is kind of at a right angle to both of them, and it almost looks like a shadow of Aristarchus. And it's just madness to me. I'm gonna see if I can adjust the contrast a little bit. All right, this is what I'm looking at. I know it's not exactly right, but I feel like it's just always kind of compelled me to look at it like that. So it's this crater kind of on the corner of this very shaded square, and then it's hard to get them both in the same frame, but yeah. But obviously, it's just that it's only at this particular angle, and Aristarchus crater actually looks very different at another phase. But you can really see Schroeder's Valley coming out right now. This is prime time viewing for Aristarchus, I think. You don't get it much better than this, really. Let me know what you think, Moon Peeps. You know the deal with Aristarchus. This is the one. This is the flaming gun, or the flaming electrical scar. Yo, what's going on, Pete Johnson? Yeah, Hazmat, shoot. Let's hear the new concept that I haven't heard. Blow my mind while we watch this amazing lunar feature. Again, the quick pop-sci reference is that Aristarchus was created by an impact crater, or by an impact about 4 billion years ago, and then Herodotus was formed a little earlier than that, so 4.5 billion years ago, and then Schroeder's Valley, the kind of snaking valley that I'm talking about, was formed almost at the same time, and it's a volcanic lava tube. So that's the official explanation for what this is. the electric universe hypothesis is that the snaking channel is one of those things that is carved out by electric discharge arcing moving across the surface, creating a very sharp and scalloped edge to a snaking, almost dendritic ridge or feature. And if you could look in much closer even to this, you'll see that none of the ceilings, so to speak, on the lava tubes have collapsed, which is pretty common for lava tubes. Lava tubes on Earth only last about 10 kilometers. This is about 100 and some odd kilometers. And on Earth's low gravity situation, these lava tubes would have collapsed. We don't see any of that. So a few attributes. Further, you have the goosenecking of it, which is the fact that you have the lava tubes and rivers on Earth actually start small at the top and get wider at the bottom. But here it's the reverse. You see almost like a little snake head, and it trails off and then curves around. And in a way, it's almost doing like a snaking spiral galaxy arm. It almost is so recursive when you really start noticing the patterns. All right, so I'm jumping back to the chat. Let's see. New theory. I think government got a hold of Tesla's info. Definitely. Hazmat says there's no such force as a mechanic pull. Pull is only a descriptor. That's true. Just like wave and just like time. Oh, nice to see you, Pete Johnson. Glad you're out for breakfast, catching some moon for breakfast here. Me too. I haven't eaten anything all night, just been waiting for this damn shot. But I got it, and now I'm satiated. They swiped it all, indeed. I'm from where Thomas Edison came from. Earth. Also, what's up, Ben? How's it going? Let's see, YoQ says, I don't understand how they can trace the age of things, like I heard carbon, but we just agree that this is accurate. So I can talk about that a little bit, and I'm sure some people will think I'm a total dweeb when it comes to that, but I'm gonna try. So there's several different concepts. One of them, the main one really, is radiometric or radioactive dating. And of course, so the way this is done is that there's a machine that actually measures the decay rate of a radioactive isotope, which just means, I don't think it's simple, but really atoms are kind of made up of just protons. There are no such things as neutrons. So you can just imagine a core of particles and then a cloud of potential, which are electrons. And then scientists use tools to measure the quantity or the electric discharge of these particles. That's as far as I understand what atomism kind of represents. But the fact of the matter is you have these things called isotopes, and you have half-lives of these isotopes that are used to measure ages on Earth. And they use carbon-14 dating, which decays into a different type of element, and then they use argon that decays into another type of element, and other things like uranium and plutonium. These all have different half-lives, and what happens is once they run these elements and these atoms through certain types of machinery, you get a spectrometer reading, electron spectroscopy, and you can kind of see essentially these half-lives. Now, how that actually works, I'm still, it's still one of those things that you have to see in practice. I don't really know, but that's, as far as I understand it, that's how it works. And what happens is you have this chart reading that you match it up to that says if the half-life is this, then it's about this old. And then you use a kind of line chart to determine an accuracy range when it comes to like how accurate you want to be versus how how loose you want to be, but you'll get a larger result pool. There's some sort of like range algorithm that takes place. A lot of it is done in simulation. A lot of it is done by matching old results to new findings. So there's some of that, and then so carbon is the least carbon dating is the least effective, but they say it can accurately tell up to 10,000 years. And then you have argon dating, which is supposed to be accurate up to 30 to 50,000 years. I'm going to answer the atom question in 1 second, but I just want to finish up on dating because this is like such an important factor, and it's very hard to research without running into creationism and young Earth theorists, which is perfectly fine. Everyone's, should do whatever they want, but there is real science behind questioning how much you can actually extrapolate from radiometric dating, simply because of the fact that in order for isotopic radioactive decay rate to be accurate, you need a certain a constant of nitrogen-14 in the atmosphere of Earth in order for these dates to be consistent across long periods of time, like millions of years. So what happens is scientists, and you can go research this, that they basically institute a constant nitrogen level for Earth's atmosphere and a mass for Earth that is consistent over a 4 billion year period, and then they use radiometric dating to find results. Therefore, it's not necessarily exactly like creating their results, but they're actually looking for results within a time frame that people who believe in the theory of relativity and the Big Bang consider completely accurate. So they're looking for date ranges in these hundreds of millions of years. So the alternative theory very quickly is that electric discharge can create what looks like hundreds of millions of years of erosion in the matter of hours or days. It's that simple. So Cruzy says, have I ever seen an atom and what's inside of it? So I can just imagine from all the different experiments that I've seen online, if you look at IBM's experiments, they've gotten down to the point where they're smashing what they call light particles, which I don't believe they're light particles, but essentially they're exciting atoms, or electrons, or protons rather, in certain configurations down to the point where you can essentially see little spheres or points. And so, you could be it could really take you down the universe as a hologram, or universe as pixels, or the universe is just made of little sphere particles. But I think it's just that you can't, you could probably zoom out and zoom in forever in this universe that we live in and never really find the smallest piece or the largest piece, is sort of how I think it really plays out. So Large Hadron Collider will keep smashing particles and keep finding smaller and smaller particles, and they'll build bigger and bigger scopes and find more and more distant galaxies. So that's why it's so boring. It's much more exciting to consider that everything is actually interconnected right now. Light is instantaneous. These bugs are instantaneous on my screen. Sorry, little bugs. And so I've never seen inside an atom, and I've never used an electron microscope. But I definitely recommend listening to Theoria Apophysis talk about the cult of atomism and how it's such an insane thing to believe that you can really see inside an atom, where now we have electrons as probability functions, like clouds, essentially. So electrons are really just the measure of electric discharge from atomic particles. Neutrons turn into protons, so there's no neutron-proton nucleus anymore. And then atoms are supposed to be essentially mostly empty space, a dark matter, but really it seems like that's counter space, which is denoted by the termination of the dielectric medium in inertia, with the inertial plane. Also using words from Theoria Apophysis to describe this, but when you really see the ferrocell and you see how magnetism is really these toruses of a two-way magnetic current flow, you'll see that everything is really these shapes, intertwining and intersecting and moving around each other in these very complex forms. And we only perceive it like that because time to consciousness seems like an arrow, but there's no direction to time. And that's why you can't reify space, because space is not a thing, and there are no such things as waves, because wave is what something does, not what something is. There's this whole cult of atomism that really, like, you got to give it to Ken Wheeler for explaining it in such thorough, you know, layman's terms to really tell people how like crazy contemporary cosmology and physics really is when people are just talking about bags of particles and quantum strings and spooky dark matter, and they're not looking at anything real. They're looking at ghost particles and making up things that by committee and giving each other Nobel Prizes. And meanwhile, you know, I'm sitting here streaming the goddamn moon, and these guys have computer simulations. What's wrong with science? It's very evident, you know. Gassendi crater again. Now let's listen to some tunes because I do Light of the Moon, old school jam. How big and far away do I think the moon is? So I've definitely thought about it being all the different sizes that everybody thinks about, like 30 miles across and really close, or super duper far away. It seems like it is the distance it's supposed to be. However, I do feel like there's a bunch of magnetic kind of optical shit going on with the visual of the actual moon and optics in general. I feel that, can you imagine, essentially you're bringing in, when you look up at the sky, you're bringing in every source of light at once, which is a really huge deal because that's the whole idea of this light being photons. Can you imagine trillions of photons with energy packets hitting your eye at once? That's why it's not really the way it is. Like when you look out at space, your eye connects to a certain point instantaneously, and then you get to focus, you know, and that's really sort of what happens. So you make connections within a dielectric plasma universe. There's nothing really moving. It's just pressure densities in the ether. Is sort of how I look at it. So. Yo, what up, Cosmic Surfer? Cosmic Surfer denouncing magnets. You know, but I've also used a ferrocell and the 2-inch neodymium that Ken has, and you can reproduce the same effect yourself. Man-made magnets are just, it's just that kind of argument between like whether plastic is natural or not natural. It's obviously natural because it exists in this universe with us. I've always argued for that. I never understood that idea that like mankind is separate from Earth and plastic is artificial. Like there's nothing artificial within this entire universe because it's all natural. It's all natural. Come on, y'all, you know that. We're all the same thing. One can't be different than the other. So nothing is art. Nothing is fake or art. That's why I don't even, you know, I don't use the word fake very often. But it's come to be so mired in just anger, and people don't like that word anymore. It just doesn't mean what it used to mean. Fake used to be fun, now everything is supposed to be fake. Look at how clear Gassendi crater is. I'm just gonna tangent off back into the moon, because this is crazy beautiful. I mean, again, doesn't matter shape of the Earth right now because we got craters that don't look like they're impact craters, and we can see them, and we have physical evidence for overturning old paradigms of lunar geology right now, like tomorrow. If you know, can you imagine if you had a real, well, I want to say a real scientist. We could all be real scientists right now. Yeah, plastic is natural, stars are natural, this crater, you know, also natural is used to kind of make, to imply that aliens did it. Aliens done it, those are not natural, those are artificial structures. So them aliens did it, but of course they didn't. It's much more logical that our ancestors saw plasma events in the sky that looks like people because our nervous system looks like plasma. and those were the gods, and the gods actually terraformed the earth and probably elevated consciousness and probably killed a ton of people and turned the oceans to blood. Those are the gods, those are the mythos, and you tie in your real history. And that's why, to a lot of people, you can see it in the comments in the Electric Universe, people really feel empowered by this cosmology because it really gives you the ability to look at the world through a new lens versus looking for ways to kind of fight the status quo. The status quo doesn't care about the Electric Universe because it doesn't serve monetary gain. Electric Universe is about leveling the playing field. Obviously, it could be used to profit, but even that's not even a possibility because it's so tempting to actually level the playing field that the powers that be could never even discuss Electric Universe. Cyclid Visual says, LMAO, that concept always cracked me up. Plastic is artificial. Lol, it all comes from reality by man. It's the same as time for me, like saying that we're separate from, we move along the arrow of time. No, time is something that we have constructed within just our, in a way, limited and also in a way really wide perspective of the universe. We've applied this kind of metric of repeated patterns to imply time. But really, like, you could tell the moon to meet you at a certain time, but the moon is going to just do what it's going to do. And then we change our clocks to actually accommodate space. That's what people don't understand. They think everything is 100% locked in, but essentially, I would believe things like Planck's distance, the speed of light, the distance of the moon, everything is actually changing all the time, at every single second. A very imperceptible change. And sometimes very perceptible change. But right now, Gassendi staying here, wild shot, best shot of the season, I gotta say, so far. Or season, I mean, moon cycle. I've been waiting for a shot like this. I've been waiting for a shot like this. Also, check out the little, look at this amazing long sinuous rail or series of sinuous relays coming all the way down through along the side of Mare Humorum. This is just a killer shot, y'all, if I may say so. Hazmat says Jacques Fresco, scientific responsibility. Yep, saw Jacques Fresco. Unfortunately, he doesn't talk about Velikovsky at all, or plasma cosmology, even though he's all about this new energy stuff. I feel like this is my stance on it. Electric Universe doesn't go far enough for me. So if people aren't talking about Electric Universe, they're not even on the page. You know what I mean? That's the fact, because Electric Universe has so many facets that are so accurately, one, predict the universe, and two, describe the universe, that if you're not at least integrating it in terms of questioning other concepts, then you're nowhere, Charlie. So I'm at the point where I've integrated it, and I'm actually asking further questions, like, actually looking at lunar geology and saying, like, how did these theories actually apply to real-world events that I can look at myself? So while Thornhill is not here talking to me and preaching to me about Electric Universe, I'm sitting here essentially using Electric Universe to talk about the world. And that's what's different about other conspiracies and other theories. They don't actually help you. They're just a gossip. I don't want to say they're gossip, but they're like a rallying cry for groupthink. And look, I was part of it. I was part of tons of different conspiracies, and I remember alienating myself from people and friends because I was so vehement that 9/11 trutherism or ufology or any number of things, for concave Earth for a while. I was like certain it was that. And now that Electric Universe is in my life, I don't bother telling anybody about anything. I'm just like, let me show you. And this is what the theory is. What do you think? And it just makes it so much more approachable. And it's a shame that online it's just so rife with bullshit in the way people talk to one another. But the only way you can really fix that is just by being a better example and by treating people politely. Yo, thanks Z-Proxy. I feel like it's a goddamn epic view right now. I'm enjoying it. As I talk about it, it's getting a little fuzzier, but whatever. Look at the ramp up to the crater. So yeah, you can see kind of, yeah, it's just an amazing feature. I mean, it kind of gives you the eye trick and see like what's high and what's low, but really it's a flat floor, but it almost looks like a tree trunk. And what's interesting about that is that tree trunks really grow out of electrical nature. Nature has those dendritic filamentary structures baked into its original intrinsic geometry. That's why trees grow like with their roots all branched out. That's why when you look at this and it looks like a tree trunk, it actually feels correct. And same thing with the rays coming off of the different craters. Also look at this crazy, this is, for example, like a series of chains of craters. Chains of craters that they talk about on the moon. This, you know, in popular science is postulated to be like just like a raining down of meteors in a line, creating these little these chain craters. But it seems so impossible that that's the case. These seem like little sputter discharges to me. Stuff that I've actually seen in the laboratory. Or in factories. Check it out, zoom in a bit. This is cool. I'm not gonna pass one session without dropping this damn thing. See, this doesn't look like a giant asteroid hit the surface and broke up into pieces. This looks like something was zapping it and like sputter was coming off and landing in different spots. If I'm looking for that, do I see it? Maybe. But it doesn't look like ejected to me. It looks so organized. Yeah, like any one of us has seen an arc welder either in a garage, in the true garage fashion, in a garage, or like in a factory, just any number of times, and you kind of see the sputtering arc as the welder's torch goes along, like fixing a door or pushing two pieces of metal together. This is really what the surface of the moon actually feels like, even though it's made out of, you know, an iron-rich ore substitute. You know, it's just not, it's not metal, but it's full of iron, full of titanium, and it behaves like boiled metal, essentially, and then mixed with rock. Sounds like a genre of music that I would have liked in the 80s. Who am I kidding? Genre I would probably like tonight, this morning. All right, I'm gonna start winding it down. I do have to get to bed before it gets light out, otherwise I'm toast tomorrow. Thanks everybody for hanging out with me tonight on a really dope lunar journey. Let me know if I missed any of y'all or if you have any more questions for me. I'm probably going to take a break from streaming for a few days. I'll catch y'all on another one when the moon comes back around, or if I have a good shot of Jupiter some evening. But this has been a really fun moon cycle. We got to catch a 27% waning crescent, which is, heck yeah, always great. and talk about hexagonal cratering. Go look into it yourselves. If you find ballistic impacts that look hexagonal, please leave me a comment. And be kind to one another if you can. And if you see somebody not being kind, don't not be kind to them. Just let's try and smooth things over so we can get past all this shit we've been in so far with science. And Mare Humorum is a giant hexagon. No big deal. I'm gonna give y'all a quick shout out in the chat. Tom and Sebas and Lost Brooklyn, Hazmat and EOQ and Cyclid Visuals and Dapple Ben, Buried Axeblade, what's going on? Fast Paced and Z Proxy, and I saw Cosmic Surfer up there, and Cruzy, and who else? There's Pete Johnson, and Constantine, and Microwaved, and all you good people. Thanks so much, everybody. Have an excellent weekend. I'll catch you real soon. 5 minutes, and I'm just gonna play a couple of songs, have a last smoke for the night, and take a couple of quick shots. I'm gonna put in the focal reducer so we can see it wide, maybe see the dark side real quick. Thanks again. Peace.
Let it be the